In this video, we talk about chemical bonds. We are going to start that by looking at compounds and molecules. Now, we cannot talk about compounds and molecules without looking at chemical bonds. So, what is this chemical bond? So, really, a chemical bond is just formed um, when two atoms attract each other. So we call this type of attraction electrostatic attraction. It has something to do with electrons and protons. So when two atoms have a strong electrostatic attraction between them, um, what we result with is a chemical bond. So how does this attraction take place? For this course, we are going to focus on two ways by which atoms attract each other to form a chemical bond. So the first one is through transfer of electrons. For example, if I have sodium and I have chlorine, sodium will transfer one electron to chlorine. So what we remain with when an electron is transferred from sodium to chlorine is we are going to have a sodium that is lacking one electron, and because of that it will be positively charged. Then we will have a chlorine that has an excess of one electron. Therefore, the chlorine will be negatively charged. So now you are bringing these charged atoms together, what we call charged ions. When you bring them together, the opposite charges are going to attract each other. So there will be an attraction between the positive and negative to form something which is really close. Actually, in the end, you form a compound. So that compound or that chemical bond, so the chemical bond is between the sodium and chlorine. That chemical bond is formed because there was a transfer of an electron from sodium to chlorine. So that is one way that a chemical bond is formed. Another way of forming a chemical bond is through sharing of electrons. Now, for example, if you have hydrogen that has a single electron, so let me just put the electron here, and then you have another hydrogen that also has a single electron. What happens when you bring these two together? They'll be close together and they will decide to share electrons. One hydrogen will donate one electron and the other hydrogen will donate another electron. So this will result in a chemical bond. So a chemical bond that is formed through sharing of electrons um, is called a covalent bond. So this bond is formed through sharing of electrons. While this bond formed through transfer of electrons is known as an ionic bond. So these are the types of chemical bonds that we are going to look at. So you can think about ionic bond formed when electrons transfer to form positively charged ion and negatively charged ion. Now these charged particles will attract each other. That attraction is known as an ionic bond. While a covalent bond, what happens is you bring two atoms together and these atoms share electrons. And through this sharing of electrons, the two atoms attract each other. The type of attraction that we have through sharing of electrons is known as a covalent bond. So that's the difference between ionic bond and a covalent bond. Now, if you have um, a compound, so if you have a compound that is formed through ionic bond, that compound is known as a covalent compound. So if you have sodium chloride, this is an ionic compound. Reason is it is formed, the chemical bonding within that compound is ionic bond. We can have another compound, MgCl2. This is also an ionic compound. But the issue is, how do we know that we are dealing with an ionic compound? Generally, ionic compounds, the way for you to identify them is, for example, if I say I have MgCl2, you look at one of the compounds or one of the atoms within the compound should be a metal, and we'll see what metals are when we deal with the periodic table. And the other compound should be, or the other atom should be a non-metal. So we are saying we are combining metals and non-metals in this type of chemical bond. So if you use sodium chloride, sodium is a metal, chlorine is a non-metal. And because we have a metal and a non-metal, we have an ionic compound. And there is a reason. There is a reason why metals and non-metals form ionic compounds. The reason is metals tend to lose electrons. So metals tend to lose electrons. So it's easy for them to transfer electrons. nonmetals. Nonmetals tend to gain electrons. So what we are going to see is a transfer of electrons from metals to non-metals. When that transfer happens, the metal becomes positive, the non-metal becomes negative. Now, how do you know that in this compound we have a metal and we have a non-metal? You can look at the periodic table. So the periodic table has two sides. This part, this side is the left side of the periodic table. This side is the right side of the periodic table. On the left side of the periodic table, we have metals. On the right side of the periodic table, we have non-metals. So if you are given a periodic table and you see that a compound has maybe two elements, and you want to determine which of the two elements is a metal. For example, if I have sodium chloride, I'll look at the periodic table to say which side of the periodic table is sodium. So if I go here, I will see that sodium is here. It is on the left side of the periodic table. Therefore, sodium is a metal. Then I'll go to look for chlorine. I ask myself, is chlorine a metal or a non-metal? So I'll look at what side of the periodic table is chlorine. So I'll go all the way here and find chlorine here. So chlorine is on the right side of the periodic table. Therefore, chlorine is a non-metal. So here I see that I have combined a metal and a non-metal. Therefore, I have an ionic compound. So that's how you know whether the compound you have is an ionic compound or a covalent compound. Just looking at the periodic table here, we see this is the key for metals. So you see all these except hydrogen are metals. You can see that we have some metals which are on the right side of the periodic table, but we really don't focus much on those metals. Even these ones are metals. The now the rest are non-metals. So you can see that on the periodic table, most of the elements are really metals. But the metals in terms of ionic bonds that we focus much on are the ones like here, group 1, group 2, and some of group 3 here. These ones in between, yeah, we talk about them, but not in details. So we'll see what we mean by that. Now, if we go to this next slide, before that I told you that these metals, we don't focus much on them. So what I have done in this slide I have ignored those metals. Those metals are found here, but I have ignored them. I am just dealing with what I call main group elements. So this is group 1, group 2, 3, 4, 5, 6, 7, 8. So these are the main group elements. Now, what ions can we form from these main group elements? For example, if I take a lithium, what ion can a lithium form? If I take beryllium, what ion can beryllium form? If I take fluorine, what ion can fluorine form? Now, group 1 to 3. So let me take these 3 groups. Group 1 to 3 are the ions that the elements or the atoms form is equal to the group number. For example, lithium. Lithium is in group 1. So if it forms an ion, the ion will be lithium plus, because lithium is in group 1. Beryllium is in group 2. If it forms an ion, the ion will be Be2 plus, which means it can lose 2 electrons. That's what it means. Usually, we really don't focus much on boron, but if we take aluminum, aluminum is in group 3. So our expectation is that aluminum will form an ion that is Al3 plus, because aluminum loses 3 electrons to form aluminum ion. Now, if we go to carbon, carbon is a hard one. It can form an ion that is 4 minus. It can also form an ion that is 4 plus. So for now, I will leave carbon out. Now, these 3 groups are metals. Now, from nitrogen all the way down here, we have non-metals. So I said that in terms of metals, they form ions by losing their electrons, and usually the group number will be the charge on the ion. If the atom is in group 1, the ion will have a charge of plus or plus 1. If the atom is in group 2, the ion will have a charge of plus 2. If the ion is in group 3, if the atom is in group 3, the ion will have a charge of plus 3. That is for metals. Now, when you go to non-metals, to get to an ion, what you need to do is, for example, if I take nitrogen here, nitrogen is in group 5. So the question is, what will be the charge of nitrogen? First of all, I need to know that nitrogen is a non-metal. So we are not going to treat it as we have treated the metals. So to get the charge of the ion for the non-metals, what we do is we take the group number. So nitrogen is group 5, group number minus 8 will give us charge. So nitrogen is group number 5. Group number 5 minus 8 will give us negative 3. So because of that, this nitrogen will form an ion that is N3 minus. Oxygen. Oxygen is in group 6. So its charge will be 6 minus 8, which means oxygen is going to form an ion that is O2 minus. The same fluorine. Fluorine is in group 7. So the charge will be 7 minus 8, which is minus 1. And that means fluorine is going to form an ion that is negative 1. If we take neon, so neon is in group 8. So what we are going to have is 8 minus 8. That tells us that neon will have no charge, or it will have a charge of 0. So it will just be as neon as it is given. So let us practice what we have just discussed. What ions are formed from the following? So I'll just show you how you are going to solve a problem like this one. First, we have sodium. So first I will write what is the group number of sodium. Sodium is in group 1. So since sodium is in group 1, what will be its charge? Its charge will be plus 1. Therefore, we can write sodium ion as Na plus. What about aluminum? So as we saw in the previous slide, aluminum is in group 3 of the periodic table. Therefore, its charge will be plus 3. So if you want to draw the ion, the aluminum ion will be Al3 plus. Nitrogen, we say nitrogen is in group 5, and therefore, but we know that nitrogen is a non-metal. Therefore, to find its charge, it is group minus 8, which is negative 3. Therefore, the nitrogen ion will be written as N3 minus. Now, if we take sulfur, so sulfur here is in group 6, but it is also a non-metal, which means its charge will be 6 minus 8, which is negative 2. So we can say sulfur ion will be given as S2 minus. So the minus in the 2 minus means that it has gained 2 electrons. So 2 minus means sulfur has gained 2 electrons to become sulfur ion. That's what it means. So this one, calcium becomes 2 plus because calcium is in group 2. Fluorine becomes F negative because fluorine is in group 7. So you need to be able to navigate through these ions. Now, I can show you from the periodic table how these ions look like. So I want you to practice these ions. So these main group elements, the same with these main group elements of the periodic table. So you can see here we haven't put anything here. We haven't put anything here because some of the atoms that are found there, sometimes they don't behave as metals. That's why we really sometimes can't put them as metals or non-metals. That's why we drop them from the ions that are formed. Now, important terms that you need to learn about ions. The first one is a cation. A cation is a positively charged ion, while an anion is a negatively charged ion. Now, if we look at the examples of cations, we have all these examples of positively charged ions. In terms of anions, all these so all these are anions. So any negatively charged ion is called as an anion. So in terms of ionic compound, ionic compound is a combination. Ionic compound is a combination of a cation, and an anion. So say an ionic compound will result from an attraction between a cation and an anion. So if you want to have an ionic compound, you need to have a cation there, and you need to have an anion there. So one other thing that we need to learn about these ionic compounds is the formulas. Normally, when you are given an ionic compound, usually they'll be put in a specific formula. Um, the formula that we call formula unit. I think I'll talk a little bit about this formula unit. So an example is if I can give you two ions. Let's say I give you magnesium here and oxygen, and ask you, can you give me a formula if I combine these two ions, if I combine magnesium and oxygen? Now, to determine the formula of a compound, first of all, look at the charges. Look at the charges. What is the charge on the cation? What is the charge on the anion? After looking at the charges, see if the charges can cancel. So ask yourself a question. How do these, or how can these charges cancel each other? Can these charges cancel each other? Those are the two things that you are going to look at. How can I make them? How can I make the charges cancel each other? Now let's play around here and see what we can come up with. Now if I take magnesium, so I have Mg 2 plus and O 2 minus. So I have these two charges. And I want to make a formula. I want to form a chemical formula. I will look at the charges. This is 2 plus. So I'll say, all right, I have 2 plus here and I have 2 minus. So 2 plus, 2 minus. Let me just add them. Like plus 2 minus 2. The answer is 0. So based on this, I can say, yeah, the charges from the two ions have cancelled each other. And because the two charges cancel each other, what I do is I just combine the two. Say the formula that I'm going to make is MgO. So let me maybe have a better diagram, a better. So the formula I'm going to have is MgO. So which means every magnesium will cancel every what we call oxide. So every magnesium cancels every oxide. because the charges, they are equal in magnitude, although they are different in terms of uh, sign. One of them is negative, the other is positive. So I can really say that if I have Mg 2 plus and O2 minus, the compound that I form is MgO. That is the formula that I make. Now, let me look at aluminum chloride. So for aluminum chloride, I have aluminum, which is 3 plus, and a chloride, which is negative. Now I want to write the formula of this compound. As I said at the beginning, look at the charges. So aluminum has a charge of 3 plus. Chlorine has a charge of negative. Now, usually what I do is, which number will both charges go into? So I look at the smallest number. Smallest number where both charges can go into. So I'll look for that number. And I think that number is 3. So I'll put 3 here. Because this 3 here can go into this 3 one time. This is negative. This negative is the same as negative 1, only that we don't put the 1. So this negative 1, this 1 here can go into this 3 times. So I can do that. Say, let me find a number that can contain both charges. In this case, the number is 3. So let me get this pointer, and now once I find that number, the second thing I'm going to do is I'll say, let me have aluminum and give it a subscripts. So I've said aluminum will have X and chlorine will have Y. So I have removed the charges. I'm using some letters that are going to help me. Now, aluminum has a charge of 3. And I want to find what X is. So aluminum here has a charge of 3. But down here, I have put X. So I can say, let's say I have 3 and X. I'm going to equate. Yeah, maybe I should not do that. That would be a little bit confusing. Let me use a simpler approach. All right, so Now, first I said I need to find the smallest number in which both these numbers can go into. So if we take 3 as the smallest number, this 3 on aluminum goes into 3 how many times? The answer is 3 goes into 3 one time. So I'll just say, yeah, I have 1 aluminum there. Now we take the 1 on chlorine here. How many times does the 1 on chlorine go into 3? It goes there 3 times. So which means for every aluminum, we have for every 1 aluminum, we have 3 chlorines. So I'll write here Cl. But instead of writing the number at the top, we write the number as a subscript. So for every 1 aluminum, I have 3 chlorines. So first, I find a single number where both numbers can go into, where 3 can go into, and where 1 can go into. And we say, how many times does 3 from aluminum goes into 3? The answer is 1. So you have 1 aluminum here. How many times does 1 from chlorine go into 3? The answer is 3. So you write your chlorine here, but put the 3 down. So that makes life simpler. Another way to make it even simpler is just to put these ones close together. Chlorine and aluminum, you put them close together. So what we do is we cross the charges. So we cross the charges. We take the 3 from chlorine and put it down here. And the 1, we take the 3 from aluminum and put it down here. And the 1 from chlorine and put it down here. So in the end, you have aluminum with the 1 that came from up here, and you have chlorine with the 3 that came from up there. So you can either do crossing or just look at which smallest number contain the 2 numbers. So what this means is uh, so what this means is if I take aluminum and chlorine, I'll put them close together here, and then transfer the 3 and put it here, transfer 1 and put it here, and then I'll get my ionic compound. I'll get the formula of my ionic compound. The same thing with magnesium nitride. So if I have to solve this one, I will have magnesium here with 2 plus, nitride here with 3 minus. And I will look for a number where 2 and 3 can go into. And that number is 6. So we said 2 of the magnesium. How many times does 2 go into 6? It goes in there 3 times. So we'll say magnesium will have 3 of it. Then we ask the same question. How many times does 3 go into 6. So 3 goes into 6 two times. So n will have 2 down there. So you have your formula. Another way, as I showed you before, is you can just have 2 plus here and 3 minus. You transfer this 2 down here, you transfer this 3 down here. So you do that, you ignore the charges when you make the transfer. You just transfer the numbers only. So in the end, you have your formula, Mg3 and N2. So this is your ionic compound, or the formula of your ionic compound. So let's move on. So sometimes we have what we call polyatomic ions. If I can go back, if you look at these ions that we have here, they just have 2 atoms, like magnesium and oxygen, aluminum and chlorine, magnesium and nitrogen. They just have 2 atoms. And each ion has just a single atom. But if you go here, you see that sometimes we have what we call polyatomic ions. So a single ion can have several atoms. So for example, this atom here that we call ammonium, it has nitrogen, 1 nitrogen and 4 hydrogens. Look at all these atoms, these ions. The acetate ion has 2 carbons, 3 hydrogens and 2 oxygens. So these are known as polyatomic ions. And most of them are anions. And we have some few cations. So these ones are cations, these ones are anions. In terms of polyatomic ions, you need to be able to name all these polyatomic ions. So just practice the names. If I give you the ion, you need to be able to give me the name. So make sure that you practice how to name these polyatomic anions. Now, how do we write a formula based on these polyatomic anions? So write the formula for a compound formed when the following combine. So I'll take sodium and the carbonate. So if you want to write the formula for this, first bring them together. So Na plus somewhere there, and then I have CO3 2 minus. Now, what I want to do is I am going to transfer the 2. Actually, before I do the transfer, let me just get rid of this. Okay. So the first thing I'll do is I'll go to the polyatomic anion. I'll put them together again, sodium plus, and the polyatomic anion, I'll take this CO3 and put it in parentheses and put the charge outside the parentheses so that the transfer is easy. After I do that, I'll transfer the number of the charge and put it down here. So that is crossing. And then I'll transfer 1 from here. and put it down here. So in the end, sodium will have 2. If I put this one in bracket, it will have 1. So normally, when you have 1 here, you remove parentheses. If you have 1, you get rid of parentheses. So in the end, your formula will be sodium carbonate without the 1. So if I get rid of the whole ink, I'll say that this one goes this way, Na plus CO3 2 minus, then I'll transfer 1 to here, then transfer 2 to here to form N2 CO3 1, but because there's 1 here, I'll just ignore the 1 to form my final formula. Now the next one, I have Mg2 plus combining with CH3CO2. As usual, I put this one in parentheses and then put the charge outside the parentheses. Now I'll transfer 2 and put it down here outside the bracket, and transfer 1 and put it down here. So in the end, I'll have magnesium 1, we don't need to put 1, and then parentheses CH3 CO2, but now with 2. Now since there is 2, do not remove parentheses. Do not remove parentheses. So when you have a non-1 number, do not remove the parentheses. The parentheses should be there. So you have your formula there. Let's look at the third formula. So I have aluminum and sulfate. So for this one, I'll put them together. As usual, I'll put this one in parentheses and then bring 2 outside. Now I will transfer the 2 to go down here to become a subscript on aluminum. Then I'll transfer the 3 to go down here to become a subscript and under the sulfate. So in the end, I'll have an aluminum that has a subscript of 2 and a sulfate that has a subscript of 3. Remember, because it is non-1, so do not remove the parentheses. So this is how you deal with ionic formulas. So I want you to practice this, and we'll do more practice in class. Thank you.